let's talk some more about absolute value inequalities. And there's basically two types. If I have something like x plus 2 is less than 5, then that's saying that there's some interval, and if I measure from the middle of the interval to the edges, that distance has to be smaller than 5. So this type can be rewritten, so this is the same as writing -5 is less than x plus 2 is less than 5, which means the same thing as x plus 2 is less than 5 and x plus 2 is greater than -5. So do you see how this one compound inequality combines these two inequalities with an and in between? So that's the meaning of writing the compound inequality. So that's why we studied compound inequalities right before we did this absolute value inequality. So these are the easiest to solve because then I can subtract 2 in each spot and see that -7 is less than x, which is less than 3. So I can see that my solution set goes from -7 to 3. Now just for hex, let's think of how big this interval is from -7, 1, 2, 3, 4, 5, 6, 7, up to 0, 1, 2, 3. So it's 10. So the middle would be 5 away from either end. So the middle is at -2. So see how the distance from the middle of the interval to the edge is smaller than 5. So we have colored in all of the numbers that are less than a distance of 5 from the middle of the interval. So this is a absolute value less than. So there's two odd cases that can come up, so let's just talk about those two. If we have the absolute value of x plus 2 is less than -5, then your answer should be, oh my gosh, the absolute value is never negative. This never happens. So the solution is the empty set. And then let's think about the other way around. What about if we say x plus 2 is greater than -5? Well, the absolute value is always positive, so it's always greater than -5. So this is always true, and the solution set is all real numbers, which we write in interval notation as -∞ to infinity. So those are the two special cases that you should stay aware of, and don't just solve these problems by rote, because you'll do extra work when maybe you don't need to. The answer is null set, or no solution, or maybe the answer is all real numbers, so you should analyze first and say, the absolute value is always positive, so it's never going to be smaller than a negative number. The absolute value is always positive, so it's always going to be bigger than a negative number. So those are the two special cases. So now let's talk about the other possibility of x plus 2 in absolute value is greater than 5. So we still have an interval with -2 at the center, and you can solve x plus 2 equals 5. You get x equals 3 as one of the endpoints, and x plus 2 equals -5, and get -7 as the other endpoint. So now 3 intervals have been created. So I actually like to make a little chart because this will be handy later, since this concept is useful in more situations. So I make columns in a chart for the interval, the test point that I pick, and then is the given original inequality true or false. So the first interval is from -∞ to -7. Then we have from -7 to 3, and from 3 to infinity. So 2 endpoints divide the number line into 3 intervals. So then for test points, I find that 10s are easy for students to do mental math with, so I would probably pick -10 for my test point, and I would say let's plug this in to the given inequality and see, is this true? So I'm asking this as a question. So -10 plus 2 is -8, the absolute value is -8, and 8, which is greater than 5, so it's true. So I want this interval -∞ to -7 is part of the solution set. And from -7 to 3, 0 is included in that interval, and I also find that students do mental math really well with 0. So I would say the absolute value of 0 plus 2, is that greater than 5? Well, 2 is definitely not greater than 5, so the given inequality is false for the point 0. And here's where it's important to realize that if it's false for one point in the interval, it's false for every point in the interval, because the endpoints you have found are the only places where it can change from true to false or vice versa. So then from 3 to infinity, again, I'd pick 10, just because it's easy to do the math. And then I'm asking this question, so I'm saying, is 12 bigger than 5? Yes, it is. So true. So I also want this interval, and it's a strict inequality, so I don't include the endpoint. So it's -infinity to -7, union to infinity, and that's the solution set. This union stands for the word or, any number between any number smaller than -7 and any number bigger than greater than 3, any of those numbers will work as solutions to this given absolute value inequality. So this is my preferred way of solving these absolute value inequalities, but you can also do them another way, which a lot of students have learned before. So let me just write it again. So the other way is to do it as x plus 2 is greater than 5, or x plus 2 is less than -5. The thing I don't like about this method is often students don't know why they're doing it, and it's very much a rote process. And my least favorite answer for why are you doing this is I have no idea. So it's way rather you have an idea of why you're doing what you're doing when you're solving. So here you still get the same solution. So you get x is greater than 3, or x is less than -7. So you get the same solution set either way. This way it's easier and usually doesn't make sense to students. So I really don't mind which way you do it. I'm just suggesting that if you do it with boundary endpoint method, that method will be used again in another section, and you'll already know that. So let me know if you still have questions.